Morning. Today is day 28, and we're going to be talking about fluids. As you can tell on the lesson plan, you will see that I've changed it up a little bit where you're doing 2 sections a day, and there's no test or quiz. And what I'm going to do is I'm going to combine these reading assignments and make quizzes and test grades out of them. So I want to let you know what we're doing. So let's go ahead and get started. I'm going to start my timer. So, we're talking about what is the properties of a fluid. A fluid are materials that can float that has no definite shape of its own. So it assumes its shape of where it's at. Pressure is a perpendicular component of force of the surface area divided by the area of, which is in the form of P equals F divided by A. SI unit Pascal, PA, equals 1 Newton divided by meter squared. Kilopascal is 1,000 PA. Example problem is talking about a child who weighs 364 newtons and sit on a 3-legged stool, which weighs 41 newtons. The bottom of the stool touches the ground, 19.3. So what they're doing there is they're doing this equation, P equals FMA. Alpha Y inner. We got 405 over 19.3. We're going to multiply that, and we're going to do alpha Y inner again, 100 over 1 over inner, and we get 2.09 times 10 to the third power, which we're going to change it to 2.10 to the third power. So let me change that to a 3. Sorry. So then the next one, what you're going to do is you're going to do, it's asking you, it's asking you how much pressure changes when the child leans over. So we're going to take our 405 divided by 12.9 times 100 divided by 1, which we get 3.14 times 10 to the second kilopascal. So let's look at the question for number 1, please. It says the atmospheric pressure at sea level is about 1.0 times 10 to the 5th PA. That's my pressure. What is the force of sea level if the air exerted on the top of the desk 152, that's our weight, and 76 inches wide? So we're doing pressure times length times width, and we get 1.2 times 10 to the 5th. Number 2, a car tire makes a contact with the ground. So then what we're going to do there is we're just going to take our 4.05, number 2. And then we're going to take our 925 kilogram, times it by 9.8 newtons per kilogram, divided by 4 times 0.12 times 118, and we should get 1.0 times 10 to the 5th newtons times meter square. And if you remember back over here, 1 newtons per meter square equals how many kilopascal, and that's where we get that from. Okay, number 3 says a lead brick at 5.0 centimeters by 10 centimeters times 20 centimeters rests on the ground with the smallest face. Lead to the density of 11.8 kilograms. What is the pressure like the brick exerted on the floor? So what we're going to do here is we're going to take the weight of the brick times gravity divided by 100. And on this side, we're going to do force of gravity of the brick on acceleration. Once we get that through, then we're going to get 23 kilopascal. So then the next thing it's going to do is it's going to talk about gas laws. Well, we've already learned about gas laws in chemistry, so this is very easy. We have the combination gas law, we have the Boyle's law, we have the Charles's law, and we have the ideal gas law. All of these you have done in the past in chemistry, so I'm not going to really go over it that much. So example 2 says a 2.0 liter of argon gas has 273 Kelvin with atmospheric pressure of 101.3 kilopascal. Temperature is lowered to 120 and the pressure is increased. What is the news volume? So the only thing you're going to have to do here, take your formula, get V2 by itself, Take pressure 1, volume 1, temperature 2, divided by pressure 2, volume 2, temperature 2, Do your math and you get 6.1 liter. Find the number of moles of argon. Well, we're going to do this one. Remember this one? Number of moles equals pressure times volume divided by the RT. So here we did that equation here, and we get 0.893. And then C says find the molar mass. So to be able to do that, we're going to take this number times this one to get this answer. And so let's look at question number 6. A tank of helium uses an inflatable toy balloon with a pressure of 15.5 times 10 to the 6 PA. What is the temperature of 293 Kelvin, and the tank pressure is 0.20 meters. The large balloon will take 1 atmospheric pressure at 335. So, only thing we're going to do is our pressure 2 times our volume 2 divided by our temperature 2. But what we're looking for is, this is the equation, right? That's this one here, which is the combination gas law. And the only thing we're doing is we're changing it to make V2 by itself. We're doing our math and we get 3.4 meters. Number 7 says, what is the mass of helium gas in a previous problem? If the molar mass of helium is 4 grams. So the only thing we're doing here is we're doing the exact same thing we did up there, except we're actually going and we're taking 4 grams and we're multiplying it by that to get 5.1 times 10 to the 2nd gram. And then question number 8, tank contains 200 liters of hydrogen gas at 0 degrees Celsius, and it's kept at 156 kilopascal. Once the temperature raises 95 degrees Celsius and increases the volume at 175 liters, what is the new pressure? So the only thing we have to do here is just do our math with our P2 again, and then we get 2.4 times 10 to the 2nd kilopascal. The next thing it talks about thermal expansion. What is thermal expansion? Thermal expansion is any form of matter that causes a matter to expand because it is less dense when heated. So it gave us an example of how heat rises and the cool air actually falls in a house. And then it talked about plasma, gas-like state with a negative charged electrons and a positive charged ion. And that ends up with section 1. Now, section 2 has a lot of definitions, and there's only 5 of them, and that's all I'm requiring you to do for that. When we're talking about cohesion force, when I think about that, I think about the water spider and how the water spider can walk on the water. And the reason it is because it's a force of attraction that like particles exert on one another. Viscosity, when I think of that, I think of oil, and they have different weights of oil, and that's the internal friction of liquid. The more viscous it is, the easier it is to flow. Adhesive force is attraction force that allows acts between particles of different substances. So when we're talking about adhesive force, I think of some of that tape that you can put on the wall. You have 2 different types of attraction there, but it sticks. Then we have the difference between evaporation and condensation. Evaporation is where water turns into a gas. Condensation is where those particles of gas change back into liquid form. And when I think about condensation, I think about a glass of water and how you have ice. And the outside, you get this condensation where this is water buildup that makes whatever you're sitting on wet. And I also think about condensation at night. When you get up in the morning, you walk in the grass and it hasn't rained, but there's condensation on the ground. Okay? So, the only thing that you have to do is you just have to watch this video and you just have to write down some of this information. I have the problems on here, so if you need to pause it to look at it, you can. Some of you, these gas laws we used last year, and you just got to remember them again. No big deal. So I don't think you have a problem with that. But anyway, I hope you have a great day, and I will see you again tomorrow. Okay? Love you guys.